We are about to witness something no human has ever seen before, and it's racing towards us right now. What if I told you the most significant visitor from another star system is about to make its closest pass by our planet, and it is not behaving like anything we predicted? This is the story of Interstellar Object 3I, Atlas. And the latest data isn't just surprising, it's rewriting our fundamental assumptions about what travels between the stars. For months, the global astronomy community has tracked this wanderer's improbable journey into our inner solar system. Its closest, searing brush with the sun happened on October 29th, bathing it in intense radiation and solar storms. Now, it's speeding toward a critical December 19th rendezvous with Earth, offering an unprecedented observing opportunity. But here's where the plot twists defy all conventional models. As most comets would steadily fade after their solar encounter, 3I Atlas is performing a bizarre paradox in one key aspect. Its primary, trailing tail is dimming, as expected for a body cooling down. Yet, a strange and anomalous sun-facing plume, a feature that should not exist, is not just persisting against all logic. It's actively growing brighter and more defined. Why would a simple, inert ball of ancient ice and cosmic rock behave with such confounding purpose? The definitive clues began etching themselves into the data much earlier. At a critical distance of about 2.5 times the Earth-Sun gap, this object suddenly and violently flared in brightness. This was not a temporary cometary outburst, but a permanent, step-change jump in its intrinsic glow. This signature indicated it wasn't a local event, like a single vent cracking open. Mounting evidence now points to a global cryovolcanic awakening, a shivering planet-wide eruption of subsurface ices turning directly to gas across the object's entire surface, as if the whole world was taking a single deep breath. This profound process creates something incredible and dynamic: magnetite crystals. This powerfully magnetic mineral forms when specific water-rock reactions occur under thermal stress, meaning 3I. Atlas may now be generating its own innate magnetic field as it travels. Think about the profound implication here. The sun's heat might be activating a dormant internal engine within this interstellar traveler, fundamentally altering its very nature. Now, let's talk about its deep cosmic recipe. Detailed spectral analysis suggests a shocking kinship with an exceptionally rare class of meteorites called metal-rich CR chondrites. These are not your average recycled space rocks. They are considered precious primordial relics, formed in the cold, pristine outskirts of our young solar system's protoplanetary disk, untouched by planetary gravity and unprocessed by heat. They are packed with water, rich in nickel and iron ratios that act as catalysts, and critically overflowing with complex organic compounds. Recent landmark findings from asteroid Bennu, a similar but less pristine B-type asteroid, just confirm the ubiquitous presence of life's raw materials: amino acids, sugars, even the specific nucleotides for RNA. If a less pristine cousin like Bennu has that, what does that imply for 3I Atlas, which spectral data suggests is far richer in such prebiotic organics? Are we passively watching a cosmic seed pod, meticulously carrying the distilled ingredients for biology, make a silent delivery run through our neighborhood? This isn't just a rock. It's a potential blueprint for life itself, written in the chemistry of the galaxy. Its solitary journey is almost unimaginable in its duration and isolation. Based on sophisticated stellar kinematic maps, this object hasn't felt the warmth of a star for at least 10 million years. It has been drifting in the interstellar deep freeze, a dark iceberg in a cosmic ocean, where only penetrating galactic cosmic rays have been processing its chemistry for eons, potentially building more complex and exotic molecules. Then, our sun appeared, turning on the lights and the heat, initiating a profound metamorphosis. The rapid 16-hour spin of 3I Atlas was a crucial piece of the puzzle, ensuring the solar warmth was evenly distributed, cooking the whole object uniformly like a rotating kebab, and logically triggering that synchronized global cryovolcanic event. This wasn't a spotty, localized thaw. It was a coordinated, system-wide activation of its entire geology. So, What are we ultimately left with? A magnetic, organic-rich, water-bearing object from another star, now permanently altered by its passage through our solar system. It will swing past Earth, then past Jupiter's gravitational domain, and vanish back into the endless void. But we will have forever changed it, and it may have subtly changed our own planetary environment in ways we are only beginning to ponder. The biggest, most haunting question remains: what is its ultimate origin and true purpose? A shattered piece of an exoplankton? A deliberately engineered artifact? Or simply a stunning natural testament to how universal chemistry works across the vast gulf of interstellar space? We may never get a definitive, satisfying answer. But this upcoming December 19th pass is our best, and perhaps final, chance to gather crucial, paradigm-shifting data before it's gone forever, disappearing into the darkness from whence it came. If your mind is buzzing with the implications of this cosmic story, do us a huge favor, smash that like button. It truly helps the channel Winds of Thought continue to dive deeper into mysteries like this. Subscribe and hit the notification bell so you don't miss the next urgent update as this story evolves in real time. What will we learn in the dramatic weeks to come? One thing is already certain: the universe is far stranger, far more creative, and far more interconnected than we ever dared to imagine just a few years ago. Our solar system has reached out and awakened a sleeping giant from the profound depths between the stars, and nothing will ever look quite the same again. Imagine an ancient messenger from beyond our solar system, now on a collision course with our neighborhood, and it's packing the very ingredients of existence. This is not science fiction. This is the reality of an object currently hurtling through our cosmic backyard. What if I told you that right now, an interstellar traveler is making its way towards a close encounter with Earth, and it's doing things that defy every textbook on cometary behavior? This is the continuing saga of 3, Atlas, and the latest revelations are not just minor updates, they are fundamental paradigm shifts in how we view these visitors. For essential context, this wanderer from the stars made its fiery closest pass by the Sun, called perihelion, on October 29th, bathing in intense solar radiation and storms. Now, it barrels toward a December 19th close approach with our planet, offering an unprecedented observational window. But here's the first major curveball. As it naturally moves away from the Sun, its main dusty tail fades, as expected. However, a mysterious and anomalous plume pointing directly toward the Sun is not fading, it's intensifying in brightness. Why would a simple cosmic iceberg, composed of ice and rock, defy basic physics and expectations in this bizarre manner? The story grows even stranger when we look back. At a critical distance of roughly 2.5 times the Earth-Sun gap, 3I, Atlas abruptly and permanently doubled in its observed brightness. This wasn't a temporary flare-up or a cometary outburst. It was a sustained leap, signaling a profound global transformation of the object's state. The leading scientific theory? A planet-wide cryovolcanic awakening, where subsurface ices turn directly to gas across the entire surface, as if the object itself took a deep, shuddering breath after eons of dormancy. This specific cryovolcanic process is key because it forges magnetite, a strongly magnetic mineral. In essence, the Sun's heat may have switched on a dormant internal magnetic engine inside this traveler from the void. Think about the profound implication here. We might have inadvertently magnetized a visitor from another star system through our own Sun's activity. Now, let's decode its fundamental composition. Detailed spectral fingerprints point compellingly to a rare family of meteorites found on Earth, the metal-rich Chondrites. These aren't your ordinary recycled space rocks. They are considered pristine primordial time capsules, formed in the cold, dark outskirts of our infant solar system's protoplanetary disk, untouched and unprocessed by planetary geology. They are loaded with water, rich in nickel and iron acting as catalysts, and most critically, overflowing with a diverse array of organic compounds. And here's the stunning kicker. Recent landmark analysis of the asteroid Bennu, a similar but more solar-processed B-type body, confirmed beyond doubt the presence of life's raw materials, amino acids, sugars, and even the specific nucleotides for RNA. If a relatively processed asteroid like Bennu has that rich inventory, what does that powerfully imply about 3I, Atlas, which is spectrally indicated to be far richer in primordial organics? Are we potentially looking at a cosmic seed pod, silently and methodically delivering the foundational recipe for biology to our stellar doorstep? This isn't a mere inert space rock. It's a potential ark of biological potential. To appreciate this, consider its immense journey. Advanced stellar kinematic maps suggest it hasn't neared a star's warmth for over 10 million years. It drifted in the silent, cold interstellar abyss, where only high-energy galactic cosmic rays processed its surface chemistry over incomprehensible eons, potentially building more complex and exotic molecules. Then, our sun appeared in its view, turning on the intense light and heat of a stellar furnace, initiating a profound metamorphosis. Its relatively rapid 16-hour rotation spin was a crucial piece of the puzzle, ensuring the solar warmth was evenly distributed across its surface, cooking the whole object uniformly and logically triggering that synchronized global cryovolcanic event. This wasn't a spotty, localized thaw. It was a coordinated, system-wide activation of its entire near-surface geology. So, what is the tangible object we are left with today? A magnetic, water-rich, organic-packed visitor from another star. Now, forever changed by our sun. It will swing past Earth, then be slung past Jupiter's gravity, and finally vanish back into the interstellar void. But we have irrevocably altered it, and it may have subtly altered the chemical makeup of our local cosmic environment in return. Now, let's dive much deeper into the compelling data. The carbon dioxide to water ratio measured in 3I, Atlas's glowing coma, is about 8:1. This measurement is 4.5 standard deviations above the standard norm for native objects in our solar system. This extreme ratio indicates a highly oxidized, oxygen-rich environment with abundant carbon monoxide and nickel present. This specific chemical signature tells a story of unique processing. Some online commentators have speculated that such unusual chemistry might even hint at non-natural, industrial origins. However, planetary science provides a clear, natural explanation. We observe strikingly similar oxidation patterns in certain classes of ancient meteorites that have fallen to Earth, specifically the carbonaceous chondrites. So, while unusual for our solar system, it is not unnatural or inexplicable for an object forged in a different stellar environment. Nickel itself is cosmically not rare. Our own Earth's dense core is predominantly iron and nickel. The true peculiarity is the specific nickel-to-iron ratio detected in 3I Atlas, which is unusually elevated. But again, we find chemically comparable ratios in those same rare CR chondrites, strengthening the familial link. These specific CR chondrites are scientifically thought to be fragments of a much larger parent body that formed in the cold regions beyond our solar system's early influence. They share striking, nearly identical spectral similarities with 3I, making them our best terrestrial analogs. Now, integrate the groundbreaking news from NASA's OSIRIS-REx mission to asteroid Bennu. Bennu is classified as a B-type asteroid, considered relatively processed and altered by solar radiation over time. Yet, it has yielded an absolute treasure trove of prebiotic organics. We're talking about the confirmed detection of ribose, a crucial sugar essential for building RNA, and glucose, a fundamental key energy molecule for metabolism. Moreover, a stunning 14 of the 20 essential amino acids required for life on Earth were identified on Bennu, with a grand total of 33 distinct amino acids detected. This is a monumental discovery. The logical extrapolation is powerful. If a thermally processed asteroid like Bennu has this molecular diversity, then a less processed, more primitive object, like a dark D-type asteroid or our interstellar 3I Atlas, could possess an even greater abundance and complexity. D-type asteroids, found predominantly in the outer solar system, are darker and redder, known to be extraordinarily rich in complex organics. 3I Atlas shares that distinct dark reddish spectral color, strongly suggesting a thick crust accumulated during its multi-million-year interstellar voyage, a crust brimming with such carbon-rich material. And let's explicitly talk about the vital role of water. Bennu had water, and 3I, Atlas unequivocally has water signatures too. The presence of transient liquid water is physically possible on or within these bodies, especially during close stellar approaches. Liquid water is the universal catalyst for complex chemistry, acting as a solvent that turns simple compounds into the complex molecules of life. Therefore, 3I Atlasus likely possesses the complete suite of ingredients: water, carbon, nitrogen, oxygen, hydrogen, and catalytic minerals like nickel and iron. It is a prebiotic chemist's dream package. Now, let's visually look at the orbital mechanics. After its scorching perihelion on October 29th, 3I Atlas is now moving outward. Its peak close approach to Earth is set for December 19th. Following that, its path will carry it toward a gravitational encounter with Jupiter, making a close pass around March. A fascinating orbital consequence arises. Next April, Earth itself will pass directly through the region of space where 3I Atlas was located during its own perihelion. This means our planet might plow through any fine dust or gaseous particles it left behind in its wake. This presents a potential, albeit diffuse, secondary pathway for material from another star system to rain down upon our world. Recall the scale of its activity. 3I Atlas ejected enormous, spectacular jets post-perihelion, some extending over 50,000 kilometers into space. It clearly pumped out vast quantities of processed material. Now, let's quantitatively examine the light curve data from astronomers. The plot clearly shows that in early September, the object's brightness suddenly jumped by approximately 2 full magnitudes. Critically, this increase was not a spike. It was sustained, continuing its steep rise all the way through perihelion. This light curve is the definitive signature of a global cryovolcanic event initiating at around 2.5 astronomical units. The temperature conditions at that distance from the Sun can allow for transient liquid water to exist, and liquid water is the key that enables the specific chemical reactions that form both magnetite and complex organics. So, what is the detailed chemistry? Solar energy helps split water molecules. The freed oxygen bonds with iron to form magnetite. Meanwhile, the released hydrogen ions can readily combine with available carbon and other oxygen atoms to form hydrocarbon chains and other organic molecules. Introduce a bit of nitrogen, phosphorus, and sulfur, all commonly found in meteorites, and you have the pathway to amino acids and nucleotides. Thus, 3I Atlas might be accurately described as a floating, temporary, organic factory activated by stellar warmth. The profound implication is that the galaxy may be widely sown with such dormant seeds, silently waiting for a star's warmth to awaken their chemical potential. But significant questions remain. To what ultimate extent can these floating building blocks self-assemble? Is there a natural chemical hard limit preventing them from forming self-replicating systems? Or could, under perfect and rare conditions, a runaway autocatalytic process occur, leading to primitive, encapsulated chemical systems? We simply do not know yet. That's why direct observation is so crucial. The impending December 19th flyby provides a unique, time-sensitive opportunity. Astronomers worldwide will point telescopes and spectrometers at it, hoping to capture spectral lines that might uncover deeper clues about its molecular composition. But the clock is ticking. Afterwards, it will rapidly fade in brightness as it recedes from the Sun and leaves the inner solar system. We have a severely limited window to intensively study this once-in-a-lifetime visitor. So, what does this grand narrative collectively mean? If objects like 3I Atlas are statistically common in the vast interstellar medium, then the basic seeds of prebiotic chemistry might be ubiquitous throughout the galaxy. When such objects randomly fall into a star system, the stellar heat activates them, temporarily turning them into prolific factories for prebiotic chemistry. This line of thinking suggests that life might not be an incredibly rare, miraculous accident on planets like Earth. It could instead be a cosmic imperative, a natural outcome written into the fundamental chemistry and dynamics of the galaxy itself. We must, however, temper excitement with scientific caution. Extraordinary claims still require extraordinary evidence. So far, the evidence for it being an organic-rich body is compelling, but remains largely circumstantial, based on spectral analogies. We desperately need more direct data. That's precisely why the upcoming close-approach observations are so critically important. Every single photon of light captured from 3I, Atlas, and split into a spectrum could hold a vital clue to confirming these hypotheses. Now, consider the object's deep history. For perhaps hundreds of millions of years, 3I, Atlas, drifted in the darkness between stars. During that immense time, it accumulated a thick crust of interstellar material, complex organics, and volatile ices, processed only by the relentless bombardment of cosmic rays. Then, it finally encountered our Sun. This ancient crust is what we detect in its overall spectral signature, dark and red, similar to distant trans-Neptunian objects like Sedna. Sedna orbits in the deep freeze far beyond Neptune, out to 1,000 astronomical units. These distant, pristine worlds are also known to be extraordinarily rich in similar organic compounds. The very high carbon dioxide and carbon monoxide ratios we measure in 3I, Atlas's evolving coma, suggest that this primordial crust is now being actively cooked and processed by solar heat, releasing these gases. The nickel we detect is a key part of that active catalytic environment. Returning to asteroid Bennu provides a validated blueprint. Bennu contains not just amino acids, but also complex mixtures of salts and clear evidence of past liquid water interacting with rock. This proves that aqueous alteration complex chemical changes driven by liquid water definitely occurred on Bennu in the distant past. If a small asteroid like Bennu experienced such prolific water-driven chemistry, then 3I, Atlas, with its likely abundant water and catalytic metals, almost certainly underwent similar, and probably even more extensive, chemical transformations during its solar encounter. In fact, the CR chondrite meteorites we keep referencing are laboratory verified to contain amino acids in even higher abundances than those found on Bennu. Therefore, it is completely reasonable to infer that 3I, Atlas, is a veritable powerhouse of diverse prebiotic molecules. But could it theoretically contain encapsulated genetic code or polymers? We have no evidence for that yet, but all the necessary building blocks are present. In the right, shielded microenvironments. Perhaps within tiny pores in the rock, they could potentially assemble into short RNA-like chains. The interstellar environment itself might function like a slow, cosmic Lego factory, patiently putting chemical pieces together over millions of years. And when such a factory object approaches a star, the incoming heat dramatically accelerates the entire process. It's like flipping the main power switch to the on position for this cosmic facility. So, 3I, Atlas, might literally be in the midst of an intense, observable burst of new chemical synthesis right at this very moment. We are potentially witnessing the universe's own recipe for life unfolding in real time. Now, let's discuss a more speculative but fascinating solar connection. Some observers have noted that as 3I, Atlas approached the Sun, unusually large and active sunspot groups appeared on the solar hemisphere, broadly facing the object. Could there be a causal connection? A handful of researchers speculate that the object's newly generated magnetic field might interact with the solar wind in novel ways, perhaps triggering localized solar activity. This idea remains highly speculative and unproven. But if true, it adds another layer. It means that interstellar objects might not just be passive travelers. They could actively affect their stellar environments. Looking to the future, after 3I Atlas fades from view, astronomers will continue to monitor its trajectory until it is lost. It will become a faint, moving dot, then disappear entirely from our view. But the torrent of data collected during its passage will keep planetary scientists busy analyzing for years to come. And this is merely the preface. Next-generation telescopes, like the upcoming Vera C. Rubin Observatory, are predicted to discover dozens more of these interstellar interlopers. Each new discovery will be a fresh piece added to this cosmic puzzle, helping us understand how common such objects are. So, what does this ultimately mean for humanity? It means we are part of a dynamic, deeply interconnected cosmos. The very materials that constitute our planet, the water in our oceans, and the organic molecules in our bodies may have originally been delivered by ancient objects not unlike 3I, Atlas. We are, in a very real and physical sense, children of the stars. In the grandest scheme, 3I, Atlas serves as a humbling reminder that the universe is not a static museum. It is a continuous, flowing cycle of matter and energy, where fundamental chemistry persistently leads toward greater complexity, and perhaps, inevitably, toward life. So, as we collectively await the December 19th flyby, let's deeply reflect on our place in this astonishing cosmos. We are not just distant observers. We are active participants in a grand, billion-year-old cosmic story that is still being written. Thank you for joining me on this detailed exploration. If you wish to support more content that delves into mysteries like this, please like this video and subscribe to the Winds of Thought channel. And don't forget to hit the notification bell so you don't miss any future updates on this or other fascinating celestial phenomena. What if the most profound discovery in human history is not a signal, but a visitor, and it's already inside our solar system? This question is no longer relegated to the pages of science fiction, but is emerging from the hard, empirical data collected by telescopes around the world. We are navigating entirely uncharted scientific territory, where each new observation challenges our previous assumptions about the solitude of our solar system and the nature of what travels between the stars. Based on the converging data from spectroscopy, orbital dynamics, and comparative planetology, we must now confront a staggering, previously fringe idea that the interstellar object designated 3I Atlas could potentially harbor conditions conducive to life, activated specifically by its close encounter with our Sun. This is not a wild claim of certainty, but a legitimate and increasingly robust hypothesis that can no longer be dismissed. Given the overwhelming cascade of physical evidence gathered on this specific object and its startling parallels across our wider cosmic neighborhood, a pivotal and perhaps the most fascinating element in this unfolding story is the confirmed generation of magnetite. On Earth, our global magnetic field is a silent guardian, an invisible force field deflecting and diverting harmful cosmic and solar radiation that would otherwise shred genetic material and render the planetary surface sterile. Life, in all its fragile complexity, needs a degree of electromagnetic shelter to thrive and evolve. It is a non-negotiable prerequisite for a stable biosphere. Intriguingly, the same cryovolcanic and hydrothermal processes strongly suspected on 3I Atlas that may be forging complex organic chains also spontaneously produce this exact magnetic mineral. This means the interstellar object could be actively developing its own intrinsic protective magnetic shield from within. We already understand that comets generate a weak-induced magnetic field from their ionized gas cloud, the coma. Historic data from missions like ESA's Rosetta show this induced field can range from 30 to 50 nanotesla and can spike dramatically, up to tenfold, during powerful solar storm events. Now, intellectually scale this up. Imagine adding widespread, endogenous magnetite production across the object's surface and within its porous interior. The combined magnetic envelope surrounding 3I Atlas could become quite substantial, transitioning from a transient plasma effect to a more permanent, mineral-based shield. This transforms the object from just a rock. It's potentially a self-shielding vessel, a fortress world in miniature. It may be building its own fortress, a magnetic bubble in the void. Could such a generated field shelter and nurture delicate prebiotic organic compounds undergoing synthesis, or even cradle something far more complex? The possibility, however remote, must be intellectually acknowledged. Now, examine our most current breathtaking visual evidence. This stunning composite image, captured by a dedicated amateur astronomer on December 1st, shows 3I Atlas with crystal clarity against the starfield. See the central anomaly? The expected dusty tail, pointing directly away from the sun's radiation pressure, is visibly fading and diffusing. But this other feature, this brilliant sunward-facing jet, is not only persistent against all fluid dynamical logic, it's becoming more pronounced, more structured, and physically extended with each passing observation. This visual progression is profoundly counterintuitive. As the object cools in the weeks following its scorching perihelion, this one specific feature inversely brightens. It defies every standard model of cometary behavior, signaling ongoing, unusual, and likely deeply rooted internal activity. Something within 3I, Atlas, is actively and persistently venting material toward the very source of heat, a behavior that suggests complex internal plumbing or pressure dynamics. So, what do we concretely have before us? We have an object demonstrating a rich inventory of organic precursors, ongoing magnetic mineral creation, complex magnetohydrodynamic plasma interactions, and dynamically anomalous jet structures. Its long-awaited closest pass to Earth arrives imminently, on December 19th. Later, in a fascinating orbital synchronicity around March to April of 2026, Earth itself will travel through the precise region of space this object occupied during its most volcanically active, fiery solar pass. Will microscopic particles and volatile ices from another star system rain silently into our upper atmosphere? While it's highly unlikely we'd physically feel this cosmic drizzle, it poses a profound, almost philosophical question. Is this the quiet, gentle mechanism by which primordial planets are repeatedly primed with life's foundational ingredients? How many such subtle, cosmic deliveries over billions of years are required to tip a world from chemistry toward biology? Let's synthesize everything into a single, coherent timeline, meticulously piecing together the most probable narrative from the published data and peer-reviewed analyses. First, 3I. Atlas is likely an ancient relic, with estimates placing its formation between 3 to 11 billion years ago, potentially contemporary with the early galaxy itself. Sophisticated stellar motion analysis suggests it has not passed within the gravitational or thermal influence of any star for a minimum of 10 million years, making it a pristine time capsule from the interstellar medium. Its physical size is conservatively estimated between 0.3 and 5.6 kilometers across, spinning with a rapid period of once every 16.6 hours. During its incomprehensible eons adrift in the interstellar medium, it steadily accumulated a thick, exotic crust of complex ices and macromolecular organics, continuously processed and polymerized by the relentless bombardment of deep space galactic cosmic rays. The very specific detection of certain atomic oxygen emission lines beyond 2.5 astronomical units is exceptionally rare in astronomy and tells us unequivocally that this complex crust was deeply implanted and integrated over its multi-million-year journey, not a superficial layer. Internally, planetary scientists model it as a dense, rocky, metallic, and mechanically strong body, now shrouded by a fluffy, porous, and dusty regolith. Its fundamental characteristics spectroscopically align with the most distant trans-Neptunian objects, and, critically, with a rare class of meteorites found on Earth, the CR carbonaceous chondrites, which are famed in laboratory studies for their high nickel content and extraordinary organic compound abundance. Early spectroscopic measurements confirmed volatile gas ratios that are wildly anomalous for native solar system bodies, most notably a carbon dioxide to water ratio of about 8:1, a staggering deviation measuring 4.5 standard deviations above the solar system norm. In those CR chondrite meteorites, we have a lab-based analog. When their nickel-iron metal grains meet even transient liquid water, they rapidly corrode to form magnetite clusters. This very corrosion is a potent chemical driver, creating reducing agents that power reactions to explain the high observed carbon monoxide and dioxide abundances. Most crucially, this geochemical pathway is a known efficient constructor of life's molecular building blocks, amino acids, nucleobases for nucleotides, and simple sugars. These transition metals act as potent microscopic catalysts, dramatically speeding up the creation of chemical complexity in otherwise cold environments. The pivotal observational event occurred at 2.53 astronomical units in early September, when 3I Atlas suddenly brightened by 2 full magnitudes, a massive 6-fold increase in visible light. This critical distance coincides precisely with the theoretical zone, where solar heating becomes sufficient to initiate substantial water ice sublimation. Because of its fast homogenizing rotation, the solar heating was globally even, and the dramatic brightness surge was permanently sustained, not a spike. This combination points overwhelmingly to widespread cryovolcanism, a global thaw and outgassing event, not mere localized jetting. Post-perihelion satellite and ground-based imaging later revealed the spectacular aftermath. Multiple, collimated jets stretching over 50,000 kilometers into space, a typical broad anti-solar dust tail, and that persistently puzzling Sunward jet. High-resolution shots even show wispy, filamentary structures within these jets, a telltale hint of complex magnetized plasma dynamics at play, akin to solar prominences in miniature. Currently, its overall activity is measurably subsiding. Its integrated brightness is dimming, and its primary anti-solar tail is weakening. Yet, in defiant contrast, the Sunward jet continues to intensify and evolve. This asymmetry is a key mystery. All of this accumulated knowledge is now viewed in a revolutionary new light thanks to the returned samples from NASA's OSIRIS-REx mission. The recent granular analysis of asteroid Bennu, a mere supposedly processed B-type asteroid, found a rich, diverse suite of life's intact precursors. Specific sugars, like ribose, and a vast array of amino acids. The logical deduction is powerful. If a thermally altered asteroid, like Bennu, possesses this molecular wealth, then a primitive, organically supercharged object like 3I, Atlas almost certainly contains a far more abundant and chemically diverse set of these compounds. We are no longer speculating in a vacuum. We have a confirmed blueprint from a cosmic cousin. The converging data streams from Bennu, from distant TNOs, from chondrite meteorites in our labs, they all weave together into a single, coherent, and scientifically credible picture. This converging narrative is not science fantasy. It is a testable, evolving, and empirically grounded story of a potential interstellar seed. Every new night of telescopic observation brings fresh data that refines this story. If you are captivated by this unfolding, generation-defining cosmic mystery, please support this channel's journey to explore it. Hit the like button, subscribe firmly to Wines of Thought, and enable notifications. Here, we diligently delve into the profound intersections of frontier space science, existential inquiry, and the architecture of existence itself. Stay relentlessly curious. The universe is not only speaking, but demonstrating its principles in real time. The critical question remains for us as a species. Are we prepared? And are we listening closely enough to understand the message?